So we've represented these patterns in our little blocks today, and we've also done it on the page. And the way I would do it as a mathematician is to use symbols. So I would do something like, let's put the generation here. This is generation 1, 2, 3, 4, and 5. And I'm going to call that X, the generation. And use X to symbolize the generation. And then for the total number of blocks in the pattern at each generation, I would probably say it's 3 times X plus the constant part, 3. And this is how mathematicians would represent this pattern. We have here X is 2, 3 times 2 is 6 blue parts plus 3 red parts. And over here, you could figure it out probably for yourself, but I'll just write it down. I think we have 2 times X. And the constant part adds 1. I'm going to put my X. I'm actually going to call this one 1, 2, 3, 4, and 5. And this pattern gave us 2 bacteria. And to get this pattern, we have 4, and each of these bacteria doubled. So it was 2 times 2 gave us that 4. And here we doubled the 4. So it's like we started with the 2 times 2, and then we doubled it. 2 times 2 times 2, which gave us 8. And this one, of course, would be 2 times 2 times 2 times 2. And mathematicians, we get kind of lazy. We don't like writing out 2 times 2 times 2 times 2. So we invented a kind of shorthand. If you want to multiply something by itself 4 times, you can write it in this simple way where you put a 2 and you just put a little 4 up there above it. And that means 2 times 2 times 2 times 2. And this one, we can write the same way. 2 times itself 3 times, you just put a little 3 up there. It's called an exponent. And this is 2 times itself 2 times. And 2 is actually 2 times itself only 1 time. Doesn't really make sense. That's what we do. And 32, it turns out, we would just write 2 to the 5th here. Yeah, so if we look back at this pattern, we used X to be each generation, and X is the blue part. That's the part that changes. So we use X in our formula. When we write down this mathematically, X is the thing that can change. And over here, what's changing? What's changing is the exponent, these little numbers, 1, 2, 3, 4. That's our X value. So the way that a mathematician would write this pattern is that the total number of bacteria in the population in generation X is given by 2 to the X. And you'll notice that I did a little trick here because it would make our numbers work out more easily. I called this generation 1 and this generation 0, which is a little different to what I did over there. But it turns out that mathematicians, it all works in the pattern. That's one of the beauties of math, is that all the patterns tend to work out. That if you write 2 to the 0, mathematicians actually call 2 to the 0 1. They define it to be 1, and the whole pattern works.